Hi guys, Digital Principal and Computer Organization. This is the third semester paper in CSE, IT, A&DS and CSBS department, and the subject code is CS3351. In my previous video, I have given overview about and syllabus of the Digital Principal and Computer Organization. What is the number system used in digital circuit? What are the logic gate used to design an digital circuit? This video I am going to explain you Unit 1, the combinational logic. What is meant by combinational circuit? So combinational circuit is the circuit is going to provide an output only for the present input and not on the past and the future put. Past and the future input. So the output of the each logic gate is determined by the logical function. Logical function. If we are going to use the AND gate in our combinational circuit, it's going to perform the multiplication operation. For example, if we use OR gate in our combinational circuit means it's going to provide the plus operation. So plus operation means addition. So NOT gate is used for function of inversion. So NOT gate is going to perform the function of inversion. If we give an input as 0 means it's going to provide an output as 1. This is the basic diagram of AND gate. Sorry, combinational circuit. So if we going to provide an n input means going to provide an output for 2 or more input. Types of combinational circuit. Usually the combinational circuit are classified into so many types. Here I will mention the few of them. One is adder, subtractor. In off adder there will be a two. One is full adder and off adder. In subtractor, full subtractor and off subtractor, and encoder, decoder, multiplexer and demultiplexer. So these are all the important topic in this chapter for university examination. Next one is Boolean law. So Boolean law is used in our digital circuit for simplification. Boolean algebra is an algebra which is deals with binary number and binary variable. So binary number is usually 0 and 1. So binary number is usually 0 and 1. Hence it is also called as binary algebra or logical algebra. So the mathematician George Bullis developed this binary algebra. The variable used in this algebra is called as Boolean variable. For example, if we are using the variable like a, b, sorry, a, b, and c, x, y, these are called as Boolean variables. In Boolean algebra, there will be an three important law to reduce our equation. So first one is the commutative law, associative law, distributive law. These are all the very important law used in our digital circuit. First one is commutative law. What is meant by commutative law? The commutative law has a variable of only two variables. So it has two law. One is a plus b is equal to b plus a. Another one is a dot b is equal to b dot a. Our first law, it means if we given two input for A and B means it's going to provide the same RHS value. So always A plus B is equal to B plus A. For example, if we are given a value of A is equal to 0, B is equal to 1 means if we do the addition operation, we will get a value of 1. 0 plus 1 is 1. In right hand side, for B the value is 1 and A the value is 0, means if we are going to perform the addition operation, means we can get a value of 1. Finally, the LHS is equal to RHS. This is the logical diagram for commutative law. First law, A and B is given as two input. It is going to provide an output of A plus B. This is the OR gate and it is equivalent to B and A. First input is given as B and the second input is given as A, and it is going to provide an output of B plus A, that is equal to A plus B. This one is the commutative law of multiplication of two variables. So it can be written as A dot B equal to B dot A. This two law is moreover similar. Here we will do the addition operation and here we are doing the multiplication operation. So if here we will provide an input for A is 0 and B is 1, means here we will get an output as 0. Likewise, if we are giving B equal to 1 and A equal to 0, means finally we will get an value of 0. 0 into 1 is 0. And so A dot B is equal to 0 and B dot A is equal to 0. So LHS equal to RHS. And the next one is associative law. So what is meant by associative law? Associative law is moreover similar to the commutative law. In commutative law, we will use two variable, but in associative law, we will use three variable. So the associative law of addition is written for three variable is A plus B plus C equal to A plus B plus C. First, A is considered to be an one input and B plus C is going to considered to be an input to provide an input for A plus B plus C. Right? First of all, you need to draw an logical OR operator diagram for B plus A. Then you need to use this output as input for A. So A is input here and B plus C is one more input to provide an output for A plus B plus C. This is equivalent to A and B is first considered to be an input to provide an output for A plus B, and this is going to act as an input for A plus B plus C. If we substitute an value for A equal to 0, B equal to 1 and C equal to 1, means you will get a value of 1 plus 1 is 10, right? So 10 plus 0 is, so finally you will get a value of 1 here. Likewise, A is equal to 0, right? So 0 plus 1 is 1, 1 plus 1 is 1. So finally 1 plus 1, that is LHS equal to RHS. Associative law, there will be one more law, that is A dot B into C equal to A into B into C. It is similar to commutative second law. In commutative law we will use two variable, but in associative law we will use three variable. So this is the logical diagram for associative law. In first law we will use OR gate, but in this law we will use AND gate to provide an output. The procedure will be same for both the law. So first of all, B and C will be is combined to form one AND gate, and this output is combined with A to provide an A into B into C, and it is equivalent to A into B is first constructed to form an AND gate, and this output is joined with C to provide an output of A, B, C. Third and final law is called as distributive law. So in distributive law, we will perform both the and the OR operation. So and the OR operation. So A into B plus C is equal to AB plus AC. We are multiplying this A with B and A with C. According to this law, we perform the OR operation of two or more variable and then perform this AND operation to provide an result. So this is the logical diagram for distributive law. So B and C is going to provide an OR operator. This is the OR gate. And we will get an final output for this is B plus C. And this B plus C is going to provide an input with A to provide an final output, that is Y. Y is equal to A into B plus C. This is LHS. So this is LHS. It is always equal to AB plus AC. So A and B is going to provide an AND gate, that is multiple operation. This is fine. We will get an AB as an output, and A and C is constructed using the AND gate, and it will provide an AC as an output, and this output is going to provide an final output is this, that is Y equal to AB plus AC, that is RHS equal to LHS. If you are going to substitute any value for A is equal to 0 or B is equal to 1 and C is equal to 0 means you are going to get same value for LHS as well as RHS. These are some of the rules used in our simplification process to get an answer. So these are all the very important and Boolean algebra. So a first rule is A plus 0 equal to A. A plus 1 is equal to A. Sorry, 1. A dot 0 is equal to 0. A dot 1 is equal to A. A plus A is equal to A. A plus A dash is equal to 1. A dot A is equal to A. Dash is equal to 0. A double dash is equal to A. A plus AB is equal to A. A plus A dash B is equal to A plus B. So A plus B into A plus C is equal to A plus BC. I will explain few of the rules in here. So first rule is A plus 0 is equal to, are giving A as 1 value means will get an output as 1. So 1 plus 0 is equal to 1. If we are going to provide 0 here means 0 plus 0 is equal to 0. That is, if we are going to provide any value for A means you will get that value as an output. In this logic diagram, first I will substitute an value for 1. A equal to 1. So I will get an output as 1. 1 plus 0 is 1. And I am going to substitute 0 for A. So 0 plus 0 is 0. It means if you are going to provide any value for A means finally you are going to get that same value as an output. Rule 2. A plus 1 is equal to 1. Means if you are going to provide any value that is either 0 or 1 in this rule means you are getting the value of 1. That is, if you are going to provide 0 in 0 in A means you are going to get a value of Y equal to 1 because 0 plus 1 is 1. Likewise, if you are going to provide an A equal to 1 in this rule means 1 plus 1 is equal to 1. Next rule is A equal to, similarly all rules have this kind of procedures. Here I will explain rule 1, rule 2 and I will move on to rule 9. So A equal to A dash of whole dash. It means if you are providing an A equal to 0, right? So first of all you need to invert that 0 as 1. Again you need to invert that 1 is equal to 0. That is, if you are giving the value as input means you are going to get an same value as output. So the A is always equal to A dash of whole dash, or it is equal it will be say as A double dash. Here I am using a equal to 1. In every rule, you need to substitute where either 0 or 1 value to prove that rule. So a equal to 1. So a equal to 1 is first you are inverting, right? So you will get a value of 0. Again you are going to invert that given output. Then you are getting value of 1. So here a equal to 1 is an input. Finally for this rule you will get that same 1 as an output. This is the 10th law. That is a plus ab equal to a. It means if you are going to provide a equal to 0 or a equal to 1, b equal to 1 or 0 means finally we will get an value of a. So we can prove this rule by using rule 2 and rule 4 and distributive law. So in just I will write this rule as it is. Afterwards I will take that a in both the values. So if I am taking this value outside means here I will get a value of 1 and here I will get b. So a into 1 plus b. Here I am applying the rule 2. That is a plus 1 is equal to 1. Here I am in the place of a there will be a b. So 1 plus b is equal to 1. That is a dot 1. And if finally a dot 1, if we are going to multiply with 1 means you will get that same value. That is a dot 1 is equal to a, and this is the rule number 4. Refer that previous table. So a, here I will explain with that truth table. So a is 0 0 1 1 and b input is 0 1 0 1. So you need to have do the AND operation here a dot b, that is 0 0 0 1, and you need to in this final column is filled with a plus ab. So a is 0 and 0 ab is 0, 0 plus 0 is 0 and 0 plus ab, that is 0 is 0, 1 plus 0 is